thank you. Can you hear me well? It's just somewhere in my beard and I'm not sure if this is better. Yeah, anyway, okay. Hi, nice to see you all. My talk is, can we have a better feature store? We will discuss the concept behind feature store so you would be able to understand. So let's go, some disclaimer. So my talk represents my opinion because I will be sharing like what I think good, what I think bad, which is definitely might be different in some other circumstances, so please consider this. I'll try to be short in outlining like general items because we have internet, so you can always watch. At the end of my talk, you will have a QR code to the markdown of my presentation, so you can get and read in calm atmosphere. Yeah. So my talk based on some feasibility study which I was doing in my company once we were implementing the feature store. I was working on the prototype of the our own feature store. It is working. And I would like to open source it later. It's good to set the goals. I'm not sure, you know, if you promise something. And yeah, there is very little amount of smiles, pictures. There is a text and my voice. So sorry for this old school because I try to compensate a bit the enormous amount of smiles and pictures in other presentations. Yeah. So prepare reading and listening. Let's go. This is me. Sorry, I was a bit young, but yeah, it's me still. This is like the way how you can find me, contact through email on GitHub. I love Python a lot and Spark as well due to its design architecture. My first Python version was 2.6 and you know how disastrous it was. Yeah, currently I'm a data engineer at a company named Paylocity. I don't know what we are doing, but I'm doing data engineering for data scientists. Yeah, because this is like clear, right? I love my work in the sense of software development rather than what the company is doing. What I'm doing, I'm building data pipelines, tools for data scientists to make them more efficient, building CI/CD systems, other software development, a lot of work. I very like functional programming, immutability, Python's type and ecosystem. You will see in the code which I will be sharing with you that I'm heavily inspired by Scala. It's programming language. So can you please raise your hand who actually using feature store in their company? Wow, I was not expecting. That's cool. Guys, can you please, on slide, I just write the tool which you are using. I would be very interested in. Thanks. Okay. So what is the feature store? So it's an abstraction around data tables. By data tables, like most commonly, it's let's say Spark data frames, which is persistent on some persistence layer. It facilitates the discoverability of the features, and features are seen as the columns in your tables, basically. Through the binding of metadata to the features. So we have features in columns, we have metadata, which is binded to this, and by doing this, we are able to more efficiently discover them. Why do we need to discover them? Because in this case, we are made that the features are reusable. So data scientists are able to find features, existing features, use it instead of recreating the bicycle one more time, or the wheel, sorry. So yeah, it makes easier to consume and produce the features, and it has quite strong focus on various tooling to simplify the data scientist workflow. Like, for example, some interface to generate and training testing data sets or snapshotting. For snapshotting, you can see it's like point in time feature where you are synchronizing your features based on the timestamp. Or, yeah, more easy probably to understand is as I'd like to get my features at this point of time, so for reproducibility. You know that your pipeline will be reproducible, especially for testing. Let's make some brief overview of available solutions currently. So the most popular are Databricks feature store, which is common with within the Databricks ecosystem. Then on AWS there is a SageMaker. Then another one is Tecton, which I heard that very popular, but we completely dropped it from study because it was too expensive. Then there is other known as Feast. It is open sourced H2O feature store, Butterbee, which is like semi-open sourced. So what is in common there? All of them are using some kind of relational database management system for storing the metadata. Therefore, we need the infrastructure. Most of them do not support Spark, which is interesting, for like reading and writing, and focus on pandas. However, like for big data, Spark is more intuitive. And local development support is really terrible in almost all cases, so sounds like nobody take care of it. Of course, it's opinionated. Let's describe just pluses and minuses of Databricks and the other manager players. So Databricks, it's very feature-rich, it's nicely designed. It is very noticeable compared to others. It supports feature lookups where you're able to specify that I'd like feature A, feature B, and it will join you the table with exactly what you need. It is very convenient. It is Spark first, based on the Delta format, which is quite nice in the sense that it provides you almost exit transactions layer, and it, yeah, you could walk in time, so get in the snapshotting. What I dislike that local development absolutely forbidden. Even in the documentation, they're saying that you cannot use it locally. Metadata is table centric, so you are able to bind the metadata to tables. However, this is a feature store, so our main entity is a feature, but metadata is not supporting this. Search experience is poor. We will take a look later, like how the UI looks like. That it is like very hard to search for features. Data lineage. Lineage is how you're able to track how one feature derives from another one and get this graph. So it requires you to upgrade to so-called Unity catalog, which is just like you can see as a meta store. And this Unity catalog completely hiding your data to some nowhere. So you could access it only through the Databricks UI. And so for local development, as you can understand, it's like very hard. SageMaker, it's a AWS product integrated with it. It is nicely support local development, so it's just pip installable library. Your data is still available on S3, so you could like directly work with this. It has good integration with the Glue data catalog. This is from pluses. Minuses. It supports a very little subset of types. So, for example, you cannot have the timestamp, it's just a string. And this is really like around 30% of the PySpark data types are there only. It is not supporting reading from the feature store into Spark data frame. So it natively works with pandas only, which is for big data, again, not convenient. And for writing, it supports kind of Spark data frame, but through the external project, which is not actively developing. Another one, which is H2O feature store, which is quite nice. It's open sourced. Yeah, good local development, very comprehensive. However, deployment is terribly complicated. We were trying, we spent almost a week and there was some problems. And still we would need to maintain it. Okay, so I outlined like the most major players. The rest are still there, like copying each other. So based on the features, it's more or less the same. What can be better? The search experience. I'll show you how it looks like on the Databricks. So this is a Databricks UI, which is dedicated to the feature store. Here we see the features, but it's actually tables. So you can search, let's say, I don't know, feature updated by, but you see it's no hinting, nothing. So you should know exactly what you're looking for. Otherwise it won't show if you click. Yeah, if I make a spell, it it will show nothing. While we're here, I can show you like what each table looks like. So we have the table, it's in Hive metastore in this database. It has some description, tagging system, some other metadata information, plus permission. This is very important because like you need to control which, like who can access your data. Okay, let's go back. Yeah. So it needs the infrastructure, maintenance, and we need to deploy it. Since we have a database, need to UI. Yep. Metadata is not feature-oriented. Metadata is usually bound to tables, not features. Search experience worser. Lack of Spark support, lack of local development support. Strong push to web IDE, especially touching the Databricks. It's like almost impossible to work locally with the Databricks tooling. Interesting parts are black box because it's not open source. No help in optimizing queries. Since the only place we actually can get information about queries is through the feature store. One data scientist getting some features, and then they start working with them. So this is an excellent moment once we can get the statistics and solve one complex problem. We get back there. Interfaces are complex, not stable, so it's quite often they're like breaking the interfaces to their clients. Probably many others if we would be able to access their code. Let's take a look to our feature store. So what can we do better? And this is usually, for most of the companies, it's probably impossible since they need some commercial phase which will be responsible and they do not take a burden of developing something own. But if you can do this, then let's start from why. The reasons are same like open sourcing, so we can get community, we can evolve it together with others. Yeah, the same reasons. But otherwise, other than that, its own solution can be tuned to more specifically to companies. So you're starting from some small MVP, which is everybody understands. So it's like, and then it grows with the features together with your team. And this is quite big benefit because the team more aware of like why we are doing this change or another one, comparing if you would take some existing complex solution which include a lot of features from other teams which might be not relevant to our. Yeah, not locked to the vendor, clear. Design orienteers. Yeah, let's stay here a bit. Sorry for this kind of, but it was not fitting into slide. So built on Spark and for Spark. Spark is first-class citizen for big data, so this is a good orienteer, at least in our company. I cannot imagine something more simple than the only thing which we need to do is pip install the feature store. So no infrastructure, nothing, just pip install our feature store and set the configuration in some plain text file. Imagine this is like, would be really cool to get. Feature-centric, so no features for, no metadata for tables, but more binded to the features, since this will really improve the searchability. Feature store reader and writer still should support tables because tables are first-class citizen for most of the data engineering stack. Search experience definitely should be improved, so we should have support complex searches, fuzzy finding, whatever. Metadata repository decentralized and version controlled. So in this case, we are able to avoid creating any database. Simple, extendable. It's like evident, can be deployed to any cloud. In this case, the easiest solution is just there shouldn't be any deployment at all. In this case, we achieve this. Support time travel and point in time for snapshotting. It's for reproducibility. Support setting feature level permissions, so controlling who can access what, plus hiding some important features, which is we need to hide, like GDPR, PI. And query optimization mechanism, which is question what it is. And this is a new cool part. So imagine that we are getting query statistic through our client, reader and writer. And then there is some daemon which is running on CI based on the, let's say, I don't know, schedule trigger, which is getting this statistic and produce the most optimum way how we are storing our table And how we need partition it in order to optimize it based on this data. This is just ideal, because if you was working with Spark, one of the most complex things is query optimization. It is like almost all the time the magic. It depends on data, skewness, cluster parameters. It's a really hard problem. And here we can really do data-driven decisions. Components of the system. Feature store itself, which just interacts with the metadata. Hot and cold. Hot, I mean, it's all the clients are interacting with this metadata through the table, somewhere persistent, let's say on S3 or FTP. And cold is what we are publishing for searchability. In this case, we need some version control. So and solution suggests using GitHub repo as with the CSV files, and we will see why it is cool. We need a reader and writer, which is allowing data scientists or whatever who is using feature store to read and write the tables through the feature store by accessing it by name. And query optimizer, this is the part which I was describing you, which is a cool one, which learn how better write the data, so it will be faster to access optimized queries. This is like schema of this. So we have a feature store with a metadata layer, which is publishing to the repository with the metadata. It's cold storage for searchability. Then we have some daemon, which is running on CI, for example, and optimizing our query and writing how better to save the strategy, save the data. And then we have a feature store reader and writer, which provides possibility to access our data and write in efficient manner. And we have a data. This is just example, so you get intuition how the table with the features metadata can looks like. So this is example table, very simple one. So we have a data, date, number, and timestamp. And this is metadata, which is describing this table. So we have a feature name, because it's feature-centric. We have its type, source table, primary keys, where it was created, the same date, is it valid or not, tags, description of each feature, and query statistics, which can be an array of this query, which is used by optimizer. Then the repository, which is accessed by read-write clients, can be stored somewhere on FTP, S3, or HDFS, or whatever other format, which is for your company. How the searching would look like. So, do you remember I was telling that this whole cold storage for the metadata is a version controlled as a CSV file on the GitHub. Why? This is example how it is published, and GitHub rendering CSV in a very readable manner. We can use GitHub search, which is amazing product. I was reading an article how much they invested into like make the search smarter. It supports fuzzy search, it supports complex queries, and we can take advantage of it without deploying any UI at all. Just CSV. And examples that I'm looking for dtype string, some feature which has tag E. And here I see, yeah, it's not ideal. It's still giving me the rows which is not matching, but it's very easy to find. So, and if I click on this, I'm getting exactly the table, the row in it, which is matching my search. I know when it was created, in which table. I can click and get git blame who was created, when. This is already oversees the existing searching capabilities of other tools without any deployed. Now, just basic interfaces in Python, how this end components of the system might look like. And so, the feature store itself, it needs URI, like for the hot storage, where it will be stated. Then it needs a schema. Then we have a register table, which takes table name, data frame, tuple of feature keys, it's just primary keys, tags, and description, all binded to the features itself. It's a dict. So each feature will have the tuple of tags. Then we need to be able to update table. It's simple. And then these two items are for cold storage, so in the GitHub repo. So we need to be able to update our repo and publish this as a version control system. Writer. So feature store itself, now we have reader and writer. Writer first. We need some configuration, Spark, creating the table. So we have like table name, primary keys, schema, also the tags, some supplement one, timestamp keys. It's for snapshotting. We need to have this time data. Writing table. Then it's as simple. So we just need a table name and data frame, and this is it. All the metadata went once we are creating it. We are creating the table once, writing many times. And the mode is important, so we can merge, or we can overwrite, or we can append. Because it is delta format, so merge is simple. Yeah. Okay, reader interface, just read a table, and for reproducibility, we have S of date, S of timestamp, snapshotting. Supporting get features, so we can say that I need these features, and by default imagine that, so okay, I'd like some feature A and feature B, so it should take all the tables which has this feature and join it on the primary key which is inside the metadata. But we can add also where expression, so to filter it out it will be predicate push. We will get some optimization here, and we can optionally specify which tables we would like to get. Bonus item, I think we have 5 minutes, so I'd rather skip to questions. This is linked to presentation, so you could get there and maybe in Calm to walk through, even create a merge request or questions there. And yeah, do I have a couple of minutes or better to jump to the questions?
I think we can do it. So if you need something, go ahead.
Yeah, I was thinking to show you, like at the end, what is interesting part that in my company, we end up with using the Databricks feature store due to exactly the reason that company needs some responsible. But I was building the prototype and it was so cool that I decided to give a talk about this. But if you remember, I was telling that Databricks feature store, it forbids like local development. But it is Python. With Python, we can do a lot of things. And this is how we are doing it. So if we have, this is a project which uses Databricks feature store, and we have patching technologies. And you see we are patching some Databricks feature store, some variable, which they use for validating if it is local development or not. And they have some standard names and check. And if it is matching your local development meta store, it's just raising the error that it cannot be used. So once we are patching it, we are allowing to progress. Yeah, a moment. Yeah, okay. I'm not sure how to do this, to be honest, but let me try. Is that better, guys? Okay, so sorry, I didn't know that it is not. So we are basically patching the feature store, and like because it's Python package, pip installable one, so I can trace where it is failing and like decide if I can. And with this three simple stuff, I'm able to write test and test in our application which is using it. Because without testing, we will get worse software with the bugs. If short saying. Yeah, this is what I was thinking to show you, that we can overcome some problems, but it is bad that we need to invent some magic instead that developers of the feature store support local development and testing and helping you with this, right? Yeah. Questions? Thank you.